All right, so we're always hearing that AI needs massive data sets, right? That big data is the only way to get these things to work. But what if you're a startup or a small company? You don't have a Google-sized pile of data lying around. So are you just out of the game? Well, what if I told you some new research has found a wild, totally counterintuitive way to supercharge AI, especially when you're working with small data? It's pretty cool. Okay, so here's our game plan. First, we're going to really nail down this small data problem that so many people face. Then we'll look at why the standard fixes can, believe it or not, make things worse. After that, we get to the really cool part, this new counterintuitive idea. We'll break down how it works, check out the proof, and then we'll step back and think about what this could mean for making AI accessible to a lot more of us.
All right, first up, AI's small data problem. It's so easy to picture AI as this thing that only giant tech companies can do because they have all the data in the world. But for, most businesses, startups, that's just not the reality. They're starting from a completely different place and they hit a wall pretty fast. And this quote from the paper really hits the nail on the head. We're not talking about some abstract theoretical issue here. This is a real-world problem. For small and medium-sized businesses, getting enough data is a huge bottleneck. You can't just tell them, hey, go get more data. That's not how it works. They need something that works with what they've got right now.
So when you don't have enough data, your AI model often runs into a problem called underfitting. Think of it like this. You're trying to teach it a complex idea, but you only give it one or two simple examples. The model just doesn't have enough to go on, so it learns a super simple and wrong lesson. It fails to see the real pattern, so its predictions are, they're just not good.
Okay, so what do people usually do about this? Well, this is where it gets kind of weird. The most common tool that everyone uses was actually designed to solve the exact opposite problem. And if you use the wrong medicine, you can end up making the patient even sicker. So just to make sure we're on the same page, let's quickly break this down. You've got underfitting, where the model is way too simple and misses the point entirely. But then you have its evil twin, overfitting. That's when the model is too complex, and instead of learning the pattern, it just memorizes every little detail, including all the random noise. It's like a student who crams for a test by memorizing the textbook word for word, but doesn't actually understand anything. And the go-to weapon against that overfitting problem? It's called regularization. All you really need to know is that it's a technique that punishes the model for getting too complex. It's basically an algorithm's way of saying, hey, keep it simple. The goal is to make sure it learns the real lesson, not just the noise. And boom, there's the paradox. Your model is already struggling because it's too simple. That's underfitting, right? So what happens when you apply a tool that punishes complexity? You're just making it even simpler. You're literally pushing it further in the wrong direction. The cure is making the disease worse. So this is where the researchers had this brilliant, kind of crazy idea. They thought, okay, if punishing complexity is the wrong move here, what if we did the complete opposite? What if, instead of punishing complexity, we rewarded it? And this slide just lays it out perfectly. The old way, regularization, calculates its final score by looking at how well it fits the data and then adding a penalty for being too complex. This new idea, anti-regularization, just flips the math. It looks at the data fit and then subtracts a penalty, which is the same as giving it a reward for complexity. It's encouraging the model to be a little more creative and dig deeper into the small amount of data it has. Okay, I know what you're thinking. Wait a second, isn't that super dangerous? If you just reward complexity, won't the model go completely haywire and just start making stuff up? And yeah, that's a great point. You're absolutely right to be skeptical. But the secret isn't just to reward complexity, it's to do it with a really smart safety net. Here's the real magic. That reward for complexity, it doesn't last forever. The best way to think about it is like a set of smart training wheels on a bike. They give you that extra stability when you're just starting out and feeling wobbly. But as you get better and more confident, they slowly lift up and get out of the way. It's the same idea here. And this is basically how those training wheels work. It's a 3-step dance. Step 1, you start strong. When you have almost no data, the reward is really high, giving the model a big push to explore. Step 2, gradual decay. As you feed it more and more data, that reward starts to fade away. And finally, step 3, fade out. Once you've got a decent amount of data, the reward disappears completely, and the model just continues learning like normal. And it's not just the fading reward. There are other safety nets built right in to make sure nothing breaks.
You've got things like trust region constraints, which are kind of like putting up a fence to create a safe playground for the model to learn in. It can't wander off into crazy territory. Then there's gradient clipping, which is basically a speed limit on how fast the model can learn, preventing it from making sudden, reckless changes. It's a whole system of guardrails to keep things on track. Okay, so the theory sounds amazing, right? But the billion-dollar question is, does it actually work? Well, let's look at the results. First, let's check out a task where the AI has to predict a number. This table shows us the error rate. Lower is better. And just look at this. With anti-regularization, or AR, the error is lower across the board. But check out that top line. When they only used 1% of the data, the improvement was huge. That's proof right there that it's solving that early-stage underfitting problem. So what about something tougher, like classifying images? Here, they measured something called calibration error. It's basically a measure of how overconfident the AI is. You want this number to be low because it means the model knows what it doesn't know. And look, again, anti-regularization wins. It makes the model better calibrated. So you don't just get a more accurate AI, you get one that's more trustworthy. So we've seen the problem, we've seen this really clever solution, and we've seen the proof that it works. Now, let's just zoom out for a second and talk about why this really matters. So when you put it all together, what do we have? We have a tool that lets you get good results even with a tiny data set. It beats back underfitting without accidentally causing overfitting. It makes your AI more reliable, more trustworthy. And maybe the best part, it's easy to plug into the way people already train AI models. This literally lowers the barrier to entry for anyone who wants to get into AI. Which leaves us with one last big question to chew on. For so long, the story has been more data, more data, more data. But maybe we've been looking at it all wrong. What if the real thing holding AI back from being everywhere isn't a lack of big data, but a lack of the right tools for small data? Pretty powerful thought, isn't it?